Hi, and welcome to Lesson 5. In this lesson, we will be dissecting the numerical reasoning section of cognitive ability tests. Math casts fear among most of us, and when it comes to a cognitive ability test where calculators are not allowed, it basically requires us to go back to some elementary school skills, including percentages and ratios and decimals and fractions, things that most of us may have forgotten ever since. And I strongly recommend that if you feel like math is your weak spot, just dedicate enough time to removing rust from those basic skills. And it should be quite easy to do that. You can pick up on those skills quite fast if you have enough time and the right preparation resources. So I thought it's important to mention this before we move on to actually solving some questions. Take that into account. Let's start. There are 4 question styles in the numerical reasoning section of cognitive ability tests: number series, number value, word problems, and a 4th, yet less common style, which is number analogies. We will now review these question styles with sample questions. Each question will have a time limit to keep you challenged, and please prepare a pen or pencil and some scrap paper. There are 2 types of number series questions. The most popular one is a sequence, and the less common one is a number matrix. Try solving this classic sequence question in 25 seconds. The next number in the sequence is 11, as seen in answer 2. We start by jotting down a few options that can explain the changes between the first and second terms in the series. Moving from the first to the second term can be either done by addition or multiplication. If we repeat the same process for the second and third terms, we see that even more options are revealed. We now need to repeat the process again and see which of our hypotheses work. We then arrive at a rule of +1 times 2, +1 times 2. Try solving the following number matrix question in 25 seconds as well. Here again, we need to apply the same trial and error method, but in this case, we work through the column and/or the row. Starting with the first row, we can see that there are 2 options for moving between the first and second cell, and then 2 more options for moving from the second to the third cell. We can try to validate our assumptions in the second row and then eliminate anything that doesn't work. Therefore, the correct answer is 180. The next question style is called number value, and in most cases, we're asked to find which number has the lowest value. The numbers could be presented in simple fraction form or in a mix of decimals and arithmetic operations. Knowing percentages, decimals, and fractions can make your life easier in these questions. Same goes for quick tricks to estimate the size of fractions by converting them from one form to the other. The more basic fractions you know by heart, the quicker you can solve these questions. Here's an example of a sheet that you can print out and then memorize it towards your test. A similar yet more detailed list in PDF format is available in this lesson unit. Try solving this question now in 30 seconds. Let's look at 2 out of a few possible ways to solve this question style. There is no single correct way here. It really depends on what works best for you. One method is to use our memory in converting fractions into percentages. We could turn 2/3 to be approximately 66%, and 5/6 can become around 80%, and so on. In another method, we use the common denominator principle. We split the answers into pairs and then check per each pair who's the smallest, and then match the 2 remaining numbers in the same fashion. In the first pair, you can see that by dividing 5/6 by 2, we arrive at a fraction with the same denominator as 2/3. We can now easily compare the 2 fractions and determine that 2/3 is smaller. In the second pair, I've multiplied the numerator of the first fraction by the denominator of the second fraction, and repeated the process for the second fraction. This allows me to compare the fractions via whole numbers. And when repeating this process again, we find that 4/7 is the smallest number. Word problems are another popular question style in cognitive ability tests. They can span around multiple different concepts in math, including basic arithmetic, work rate, distance, speed, and time, ratios, percentages, and averages. Try solving the following percentages question in 45 seconds. In word problems, we need to isolate key phrases or sentences and turn them into equations. The first sentence part that should become an equation is its price rose by 20. 20% of 12 can be found by using the 10% block trick. 10% in the case of 12 is 1.2, as you simply shift the decimal point 1 place to the left. If 10% is 1.2, then 20% is 1.2 times 2, which gives us 2.4. Looking at the second phrase that should become an equation, we have additional 2.4, which is 4.8. This is the total amount of money that reflects the increase. Now we need to find how much 4.8 is out of 12. One way is to write a fraction, which is 4.8 over 12, and multiply it by 100. That would give us 480 divided by 12, which is 40. Another way is using the previously calculated 10% blocks. We can see that 4 units of 1.2 equal 4.8 in total, which means 4 units of 10% each are 40% in total. So the correct answer is 40%. Percentage problems can be solved quickly by using a few simple tricks. Here are a few of them. Finding 10% and 1% of any number can help speed up your calculations. We do this by simply moving the decimal point, either once or twice, to the left, respectively. The second trick is that for numbers that end with a 0, you can easily find the missing number by multiplying the biggest decimal units of the percentage and the number. For example, 20% of 30 is actually 2 times 3. In the same way, 25% of 40 is 2.5 times 4. Another trick is that for any pair of numbers, you can switch between the percentage and the whole number position and still arrive at the same result. And lastly, for reverse percentage questions, it is recommended to understand and then memorize those 2 formulas. And for the final question style in this section, number analogies are quite similar to number series in the sense that you have to decipher the mathematical relationship between 2 numbers. Take this question for example. 1 to 5 is as 6 to? Well, the two most immediate options that come to mind here are either addition of 4 or multiplication by 5. We need to make use of the answer options in order to determine which of our hypotheses is correct. This brings us to the end of the lesson. Please note, the lesson includes a PDF file with a list of curated practice resources in numerical reasoning. Those resources are available for free on the internet and are worth reviewing, so please don't forget to check it out. And on to Lesson 6, which focuses on abstract reasoning.